Hello viewers, welcome back to the course on scientific computing in Matlab. So today we will continue with the previous lecture and try to make the Matlab code for cubic spline. So let us do that one. So we know that in the cubic spline, I know that we have the data points. So suppose this is my data points, and in all these data points I am approximating with a spline which is satisfying few properties, that its function should be smooth here, first derivative will be same, the second derivative will be same at these points. So that this way we can define the cubic spline. So in each of this sub interval, so this is my basically sub intervals. So I can define the cubic spline in any kth of the interval. So that is given by sk0 plus sk1 x minus x square, okay, plus sk2 x minus x square whole square plus sk3 x minus xk cube, and in this case my x belongs to xk plus 1. So that is the cubic spline we are going to get, and then I also know that these values we have to come across. So to solve this value we have to come across the system of equation. So that is represented by hk minus 1 mk minus 1 plus 2 times h k minus 1 plus hk mk plus hk mk plus 1 and is equal to 6 times dk minus dk minus 1. So this is the we are getting here, where my hk is xk plus 1 minus xk, and dk also, that is equal to yk plus 1 minus yk divided by hk. So this is the way we have defined this one. Now today I am going to use the Matlab code for natural spline. Now if you see from here, this is my, I just call it equation number 1 and 2. Now what I do is, this mk we know that this is, if I put m0, so that is s0 second derivative, m1 second derivative. So that this is the way we can find. Now in the natural spline it is given to me that s0 double dash, that is my m0, that is equal to 0, and sn, that is 0. So at this boundary points the value m and n, m0 and mn, that is 0. So this is given to me. Now from here, so this is equal to k 1, 2, 3 up to n minus 1. Suppose I have the points x0, x1, x2 up to xn. So I will go from 1 to n minus 1, because if I go k is equal to 1, I have to go m0. So that is the boundary point we are going to solve. Now from here if you see, then how we can make the, how we can solve this for the values of mk's. Now if I put k is equal to 1, I will get h0 m0 plus 2 times h0 h1 m1 h1 m2 is equal to 6 d1 minus d0. So that is, so this is known to us, what is the d1 and d0. I also know H0, H1. So, only thing I need to find M0, M1 and M2. Now, the next one will be K is equal to 2. So, it will be H1 M1 plus 2, H1 plus H2 M2 plus H1 H2 M3. So, this is gives the M3, that is 6 D2 minus D1. So, if you see from here, I can continue with this one, and in the end if I put n minus 1, so K is equal to n minus 1. So, if you put n minus 1 here, so what I will get? I will get H n minus 2 M n minus 2 plus 2 times H n minus 2 plus H n minus 1 M n minus 1 plus H n minus 1 and M n, and that is giving 6 D n minus 1 minus D n minus 2. So, I am putting n minus 1 here. So, in the end I will get this value. Now, if you see this system, then it gives you first one. So, only this problem comes here, that what is the value of this and this, because the boundary points are involved. If you see from here, then this is a system of n minus 1 equations, and the number of coefficients are M0, M1, Mn. So, in that contains n plus 1 coefficients, n plus 1 variables. So, this is a n minus 1 equations and n plus 1 variables. So, now to solve this system, we have to find the value of these boundary points. So, this is the way we can define the natural spline. So, in this case what I can do is that I will take this one on the right hand side and I will write it here minus H0 M0, and the same way I can take this one on the right hand side and I will write minus Hn minus 1 Mn. Now, from here you can see that it will contain n minus 1 variable and n minus 1 equations are there. So, now it is a square matrix. So, now based on this, what is the value of my M0 Mn, I will put it here and I will solve this system. So, if you see then this system becomes a tridiagonal matrix with first is 2 H0 plus H1 and then H1. Next is H1 2 times H0 plus H1, then H2 and so on. In the end I will get 2 times Hn minus 2 plus Hn minus 1. So, this is we are going to get Hn minus 2 plus Hn minus 1. So, this is a tridiagonal system. I will get M1, M2 up to Mn minus 1. So, this I need to find, and on the right side it is given that the first coefficient is given. This is the first one coming here, then all this here the value is coming, and the last this is the value. So, that is known to me, this is known to me, and this I need to find. So, this matrix if you see, then this is a tridiagonal matrix, and you can see also this is diagonal dominant and diagonal dominant matrix. So, this system will have unique solution, and from that solution I can find the value of m1, m2, mn minus 1 directly from here. Once I know the value of this one, then I can find out my cubic spline. So, from here I find out that directly after solving this one, I can find my coefficient xk0. So, that will be yk, sk1, so that will be dk minus hk 2 times mk plus mk plus 1 divided by 6, sk2, that will be mk by 2, and sk3, that will be mk plus 1 minus mk divided by 6 hk. So, I am able to find all this coefficient. So, now I know the value of yk is already given to me, mk is I found from this system, dk is given. So, now I can find the coefficient, and based on this coefficient I can write my cubic spline. So, this is my cubic spline I am able to write. Okay. So, let us try to make the Matlab code to solve a cubic spline problem. So, let us try to find out. So, here I have introduced the concept of the Matlab code for cubic spline. So, in the cubic spline I am passing x and y, and I am getting back the value of s. So, this is the splines we are going to get, the coefficients basically. Now, from here this is my n, I am introducing this n, that is the length of x. So, h is the difference. So, this is diff means the difference of x. Like here I have the value, suppose in the previous one I have x. So, I will write diff x. So, diff x gives you 1 minus 0 1, 4 minus 1 3, and 5 minus 4 1. Similarly, I can find this is my y, and I can define the difference of y. So, that gives you 8 minus 11 minus 8 3, and so on. So, this way we can define the difference. The capital D is the difference of y divided by h. So, this is the divided difference. A, I define the matrix with dimension n cross n, and B is the vector I am defining that has that is a column vector of dimension n, because here I am going to introduce the system A x is plus B. Now, I want to find the value, the matrix A. So, A matrix as we have already defined. So, this is going from 2 to n minus 1, because the length is from 1 to n. So, I am finding in between. So, this is 2 to n minus 1. So, this is the coefficient of a k minus 1, that is h k minus 1. At the diagonal elements, the value is 2 times h k minus 1 plus h k, and the next one value will be h k. So, that coefficient we have found, and on the right hand side it is 6 times d k minus 1. So, that we already know that how we have defined this one in the case of this way. So, this is the basically matrix I have written there. Okay. So, I have written this one matrix starting from here. Only thing is that at the first row and the last row we have to write it separately, because here the first row and last row, that is having different form as compared to this one. So, all other rows have the same form, that is the 3 points are there, that is why it is triangular. Only the problem is coming in the first row and the last row. So, let us try to make this one. Now, in this case I have written these things for all the values of k. Then I will, what I do, I will take the, so this is my basically a matrix A. I have started with n cross n. Now, in the n cross n, from second row to n minus 1 row, and from second column to n minus 1 column I have written the coefficients of that matrix. Okay. Then what I do is that, and this is the right hand side vector. Now I put the solution. So in this case I am taking the natural cubic spline. So my m0 and mn is 0. So on the right hand side, if I take on the right hand side, does not matter, because m0 and mn 0. So my right hand side will be same for all the values. So this is the same value we are taking. Now I find the solution. So in the solution what I am going to do is that I am taking the matrix, the interior matrix starting from 2 to n minus 1 and 2 to n minus 1. So from here you can see that I am taking the matrix that is lying in between, because here taking the inner part of that matrix. So 2 to n minus 1 and 2 to n minus 1, then backslash, and B on the right hand side I am taking the points from 2 to n minus 1. I am leaving the first and the last one. Now from here I find the solution of the interior matrix. Then from here I will get the value of m's in the interior. So that is getting, I am getting the value of m1, m2, m up to mn minus 1, and m0 and mn is known to me. So this is the value of m0 and this is the value of mn. So I putting here 0, and in between the solution I am going to get. So this solution we are going to get will be the column vector. So I am taking solution dash. So it is a row vector. So this is my m we are going to get. So this m will contains all the second order derivatives of the cubic polynomials, cubic spline at the nodal values. Now from based on this one I find the value of coefficient. So I find the value of coefficient from k from 1 to n minus 1, because I am introducing k plus 1, and so that is why I am taking the value 1 to n minus 1. So sk1 is mk plus 1 minus mk divided by 6. So I am going to write this coefficient. So I am writing, this is the coefficient of x cube, this is the x square, this is the coefficient of x minus xk cube, x minus xk square, x minus xk, and this is the last one, the constant one. So that coefficient I am calculating here. So I am sk1 is this, sk2 is mk by 2, sk3 is dk minus hk multiplied by 2 times this by 6, and the sk4 is yk, whatever the value we are having here. So this is the end of this one, and I passing this as the coefficient as s here. So this one I saved. So this name is the cubic SP. So let us try to run this one. Now I will this value we can comment, and then I can uncomment the data for the cubic spline. So this is the data we can do uncomment. So that is the data we received. So let us start with the x and y. So let us take the first one. Now I am taking this x as 0, 1, 2, 3, 4 points, and y is this value. Now I call the function cubic spline xy, then I get the value of s. So the row of s are precisely the coefficient of the cubic spline, because if you see in this case the cubic spline, if you see that this sk, k is moving from 1 to n minus 1. So I will get the matrix whose first column is this value, the second column is this value, third column is this value, and fourth column is this value, and these are all the rows. So, I get from here the matrix of dimension n minus 1 cross 4. So, that matrix we are going to get. So, let us try to run this one. This one. This one, error. So, this is my m, the coefficient I got 0, 2.4, minus 3.6 and 0. So, this is the end points that was already 0 and this is the in between points, and this is the rows of the coefficients, the cubic spline. So, that is the 0.4, 0, 1, 0. So, this is the first cubic spline in having, so this is my x. So, from 0 to 1 this is my cubic spline, from 1 to 2 this is my cubic spline, its coefficients are there, and from 2 to 3 this is my coefficient. Okay. So, now we have to, what is this error? Now maybe I have written somewhere, oh this is a comment, so that is why it is not coming. So, let us try to run it again. This is also, I have to, and that is it. So, now it should come. Now, from here let us see that what is the answer. So, this is the way we have found this one. Now, I want to plot this. So, using this command I try to plot this cubic spline. So, you can see from here that from 0 to 1 that is my cubic spline, from 1 to 2 this is my cubic spline, and 2 to 3 this is my cubic spline. So, from here you can see that this cubic spline is a smooth function, smoothly passing from one subinterval to the another subinterval at this connecting nodes. So, that is why it is a smooth function. Now, the question is that how we can find out. So, this is the way we have done. So, as I already displayed to you. Now, what I am going to do is that I am going to plot this function. So, x1 to x2, so that is 0 to 1, I am dividing this one into the 100 parts, so that I should be able to plot the function nicely in this interval. And here I am putting this polyval. So, polyval, I told you that the first row represent the first cubic spline. So, I am taking the first row and all the columns. So, this is my first row, and I am finding these values at each x1. So, whatever the value of x1 minus x1, because the coefficient will be x minus xk. So, in each of the interval. So, x1 is 0. So, that is why this value I am getting get. Now, for the next cubic spline the same thing I am going to do, only thing is that it is now x2 minus x2. So, x2 is basically 1 in this case, and x3 is 2 in this case. So, based on this one I get this y1, y2, y3, 3 values for this value of x. So, this one is I have done only to test this function. And then I plot this all this together. So, x1 y1, x2 y2 and x3 y3. Okay. And this is the corresponding x and y whatever we have started with, and I am plotting together with this, the connecting side is the circle. So, from here this is the what we are going to get. So, this is the first cubic spline, the second cubic spline and the third cubic spline. Now, somebody asked me that okay, we got this spline, so I want to find the value at 1.5. So, what will the value in 1.5 or what is the value at 0.5? So, in this case we have to choose. Now, suppose I want to find the value of this approximating the value at 0.5. It means I have to choose the first cubic spline. If I want to find the value at 1.5, I have to choose the second cubic spline. Okay. So, in this case, suppose I want to find the value of x at 0.5. So, I will so suppose I want to find the value of x is equal to 0.5. Now, at this x, I will write this value. No, x is equal to 0.5. So, this is the value of x. Now, I write this one approximate value. So, I write approximate is equal to the polyval. Now, I have to choose in this case S1. So, S1 I am going to choose because 0.5 belongs to this. So, I have to choose the S1, right. So, let us take the S1 and this is the x we are going to introduce, x minus 0, because that cubic spline is this one having the coefficient 0.4 and 0.1. So, this is the value we are going to have and that is the value 1 is coming. So, from here I can approximate that the value of this is 1. So, from here point 1, yeah, that is why I was a little bit. So, this is the value I am going to get. So, that is a 0.1. Now, the same thing I want to verify for 1.5. So, 1.5 it should be 1.4 or 1.3 somewhere. So, let us try to find out. So, x is equal to, suppose I want to find at 1.5. So, in this case my x was, because my coefficient capital X is 0, 1. So, it should be from 1. And that should be 2. So, it is 1.325. So, you can verify also from this graph, then it is coming 1.325. So, it is 1.325. So, the same way we can define for 2.5. So, it should be somewhere. So, let us try to define the value at 2.5. So, suppose I take x is equal to 2.5 and then it is falling in the third polynomial cubic spline and the third is passing through the 2. So, it is 1.97. So, it is coming 1.97. So, you can see that it is my 2 and coming at 1.97, close to 2. So, it is 1.97. So, that value is given. So, this way we can find out all the cubic splines and based on this one, let us try to take the another data. So, let us take the another data. So, this is the function I am taking, x raised to power 1 by 3. So, cube root of x I am taking here. So, let us try to solve this one. So, this is the cubic spline we are going to get. So, I have 4 points 0, 1 at 1, 2. So, 0, 1, 8 and 27. So, 0, 1, 8 at 27. The value of y is 0 at 0, 1 at 1, 8 at its value is 2 and this is 3. So, this is my cubic spline we are getting for these values and from here if I find the value of s. So, this is my first cubic spline, the coefficient of the first cubic spline, this is the second cubic spline, and this is the third cubic spline. So, from based on this one I can find the 3 cubic spline. The same thing you can define for any number of datas. Suppose I just increase the number of points here. So, let us try to find out. So, I take it 64 and 125, suppose I take this one, and then I take it 4 and then 5. So, let us increase the data. Just I have increased 2 raised to power 3 is 8, 27, 64 and 5. So, let us try to run this one. So, this from here you can see that this is the cubic spline we get, and this is the last two one. So, I have to add this point there in this case. So, I have to define the 5th degree polynomial also the same way, and only then we can plot all this figure. But from here you can see that the matrix is a 5 cross 5 matrix. So, this is the same. So, these are the coefficient of the polynomial, and from here if I introduce the same way x 3. So, let us try to do this one. So, I will call it x 4, x 4 to x 5, and this is y 4, 4, 4, and then I define this 5, 5, 6, 5. And now based on this one I can plot this. So, here I can add x 4, y 4, x 5, y 5. So, let us try to so this is my now 5th degree splines. So, this is the first one, this is the second one, then the third one is this, fourth one is this, and 5th one is this. So, based on this one, the number of points we have, we can plot all the cubic splines in each of the subinterval with the help of this program. So, I have given you the only few examples that involving only few number of data points, but you can extend this one for any number of data points. So, this is the way we can define the cubic spline function. So, I will stop here today. So, today we have tried to make the Matlab code for the cubic spline, and then we have plotted the cubic spline and found that the cubic spline is a smooth function in the given interval or in the for the given data set points. So, thanks for watching this. Thanks very much.